Thank you, everyone, for having me. This is a long trip for me to come out from San Francisco to one of my favorite countries, so I'm really happy to not only get to spend some time with the locals, but to also get to share some of the work that we've been doing as well. In these 25-minute sessions, we're going to try to move fast, so I will do my best to keep this crisp. And I wanted to start a little with where I came from, and then we're going to talk about some of the tips that we've picked up and that we rely on when we're building out our data science program at Coinbase. In my background, before I worked at Coinbase, before I worked at NASA, I worked at a startup called Apogee. We took this through one of the larger startup incubators, and you might just have to take my word that there's some content up here. But we took this through one of the startup incubators in San Francisco, the Y Combinator. I hear there are a lot of incubators in this country as well that I'm looking forward to getting to spend some time with in the next couple of days. After working at that startup in San Francisco, I left to work on what I saw as some more interesting data problems at NASA's Jet Propulsion Laboratory in Pasadena, California. And in the last year, I came back to the startup scene to join Coinbase, where I'm now a director. And in the work that we were doing in data at NASA, where I'm going to start, we saw over the course of our history, over the last 60 plus years of launching spacecraft, we've slowly been increasing our data rates. And in the last several years, where we were in previously the kilobit per second range, we ramped that up to the megabit per second range, and we were doing a lot of work in the last several years operationalizing optical communication or laser communication, where we're now getting into the gigabit per second range from low Earth orbit and beyond. So we're ramping up the data collection to bring home more data than we've ever had before. And where I spent quite a bit of my time inside the agency was working on the first operational laser communication system on the International Space Station. After working on this project to increase our bandwidth so we could bring home more data, the chief technology officer at our laboratory was looking at some of the larger trends and realized that we're bringing home more and more data, but with all this data that we've collected, what kind of unfound discoveries lies in the data that we've already collected? So we joined forces, and for a couple of years, I led data science out of his office at the Jet Propulsion Laboratory. And at that time, we were seeing some trends over time for how we were collecting, working with, and dealing with our data, where in the last several decades, in the mid-90s, we had one of the main drivers or one of the main innovators that helped us collect our data was using the internet. This was what connected us. It allowed us to share our data across the various NASA centers that we had. With all the data files that we brought home, we then put these on traditional shares, and after putting it on those shares, there were some new innovations that came out that let us do bulk processing on it, and it started it started lowering the bar for us to process and do interesting things with our data. We then worked heavily in the cloud to now have more of an on-demand capability to evaluate hypotheses and work more quickly. And one of the innovations that I saw at the end of my time and what brought me back up to San Francisco was looking at the Bitcoin space. This was one of the next major steps that I saw in the data science space, where this was now a public ledger that was based upon an open data protocol, or by sharing and democratizing a public ledger, this became one of the more exciting data problems that I saw. And this was not just using data in a traditional sense. This was using data to transform a fairly old industry that had seen relatively little fundamental innovation for some time. And so this is a video of armored cars driving around, moving what's typically underneath a financial transaction. And what excited me about the Bitcoin space was the ability for us to digitize and globalize transactions. And so this is a video of our exchange where we run the largest regulated Bitcoin exchange in our country. We currently move about 10,000 Bitcoin through this a day. So there's also an increasing amount of volume that's going through this, all based upon the distributed blockchain technology, which is one of the largest distributed databases in the world right now. And so what I'm going to talk about is across those projects we worked on, some of the tips that we pulled together. And the first tip that we emphasized heavily was the ability to enable exploration. And when I was working inside NASA, we did quite a bit of exploration, not just here on our home planet, but all across the universe. And that exploration brought home a lot of brought home a lot of data. And we had data from the past almost half of a century. And of the data that we brought home, we saw something inside our agency where as we brought home more and more information, we were also collecting expertise and institutional knowledge inside of our organization. And what we saw as the fundamental data problem for us was bridging the gap between the expertise and the data that we had inside. And this is where new innovations in open source and other of the data science technologies that are being presented today helped us cross that bridge. And that's where we were finding low-hanging fruit in the middle. So a driving part of enabling exploration for us meant seeing where there was expertise inside of our agency and where there was some data that may or may not have been used where we could cross that bridge and find some new discovery. So that was the sweet spot in data science for us. And in that data science, there's one person typically that's driving that sort of innovation. This is the explorer. This is someone that's going out and looking for both the people, the expertise, and the data that we have where we can cross that bridge together. And so when we thought of data scientists inside of our agency, we were thinking of these as the explorers, the astronauts, the enablers that are going into sometimes uncharted territory to connect the people that we had with the data we had using some new technologies. And the scientist part of this is really important, where when we think about data science inside a large institution, it's not just about solving a well-defined problem. And the scientist at the end of this title is really important. And it's important because we don't always know where we're going to wind up when we're exploring. So it's important for us to be able to hypothesize. After the hypothesis, we want to be able to experiment. And once we do those two and start to tune that process, we see us as explorers inside of our organization. And some of the things that we focus on now at Coinbase to help this exploration move as seamlessly as possible is, number one, making sure that there's clarity around the classification of our data inside. One of the big disablers that we often see inside data science is when we're unsure about the sensitivity of what we're working with. If we're not sure if something's classified or controlled or it's privacy information, we tend to shy away from using it or sharing it with people around our organization. And so one of the first important steps we take is being very clear on what data you can freely experiment on. And once you've identified a pot of data that you can move quickly on, that's one of the biggest enablers that we've seen. One of the next enablers is cloud computing. So once we have all of that data, we've typically surpassed the realm in which we can analyze all of it on our laptop. And we also want to share and collaborate. And so by bringing in cloud computing in a self-service capacity inside your organization, our goal is not to have people, when they want to explore their data, come to one of our infrastructure people or our cloud people to spin up a computer. We want to put the cloud at their fingertips so they can spin it up and analyze their data with no barriers in between them and some results. Once we have our cloud, it's then really important to have safe zones and replicas of our data sets. It's really scary to be trying a new test or running a heavy analytical query on a production database. And so we spend a lot of time making sure there are replicas, or building off the first point with classification clarity, we want to have a safe zone where our data scientists and data engineers feel like they can move quickly and move freely to try new things. And lastly, we really want to encourage collaboration. When we think about tapping into the institutional experience that we have around our organization, a lot of that comes back to collaboration. We may have someone really sharp on data tools over here and someone that really understands where we should start looking over here. And being able to bring those two people together, again, without some blocker or roadblock between them, is also really important. Tip number 2, aggressively liberate dark data. And for this, I want to start with a picture in 1967. And does anybody know what this is a picture of? You've probably seen this in a history book somewhere. This is a man sitting at mission control in Houston, I believe, for one of the first launches of the moon rocket on, I believe, the Apollo 4 flight. Still a lot of smoke. Yeah, you can see his pipe sitting at the table. So if we fast forward today, a lot of things have changed. We don't have people smoking at the console. It's a little more modern, a little more digitized today. And when we were thinking about how we could enable and further data science inside the agency, we first stepped back and took a look at, well, what data do we actually have? What data is powering this mission control? And when we looked behind that, we saw a catalog of a lot of the data sources that we had, and we saw that there are 209 official data sources that were making that possible. Now, after looking at the official list, knowing a little bit about how people are doing their day-to-day jobs at those consoles, we think about maybe those are the official number, but how many undocumented data stores do we actually have inside? And when we think about the data that's being collected and where this data is then being stored, it often looks something like this. Let's see if we can get this audio. So this is a video from Indiana Jones' Raiders of the Lost Ark, where after they found the crown jewels that Indy had been searching for, they put it in a box, they put it in a warehouse, perhaps a data warehouse, and lock it away so no one can ever look at it again. And when we think about the official data sources that we have inside, or the data warehouses that are storing some of our crown jewels, we want to be careful that we're not locking away the greatest assets that we have. And so that brings me to this. Does anyone know what this is a photo of? You want to? So this is a photo. There's a small application here. And so this is a photo of what some scientists think the universe's dark matter looks like. So it's spread out all across the universe. And surprisingly, it's actually the majority of the universe. Now, what's fun about this is when we think about dark matter, we don't actually know entirely what that is. This is still a heavy topic of research, and it makes up the majority of the universe around us. So this brings me to one of our main terms that we like to think about liberating, which is dark data. And so when we think about the majority of the data all around us, what percentage of the dark data do we have that we don't actually know about, or do we not have available for our staff to use? So we define that as the data that's all around us that we can't use today. And can't use. What does that mean? So can't use can mean a few things. Maybe we can't find the data. Maybe we know it's somewhere inside the organization, but we're not sure where it's been saved or stored. Or maybe we've got that data, but it's stored in some old or some obscure format, or it's some proprietary database that I'm not familiar with how to use. Or maybe we've got it, but there's so much of that data that we can't actually process it. And for any one of these number of reasons, if we can't use our data, then we call it dark data. And we see this as a pretty painful thing that we want to avoid, because without having access to all of the data and institutional knowledge that we built up, we can't evolve. And that's really important for us as a small startup today, and many of you for the other startups and organizations looking at what's next for you. So when I joined Coinbase about 7 months ago, I had gotten to know the guys in 2012. And there was a blog post that they published in 2012 that said, we're working hard to get this ready for you, which was just one function, the ability to buy and sell Bitcoin connected to one bank account inside. And now if we fast forward a couple of years, now that I'm at the company, we've been deploying features at a fairly ferocious pace. And so we're using the data that we've collected to find out which features we want to launch next, from accepting new bank accounts, new relationships across the world, deploying more features to more securely store your Bitcoin and move that more effectively inside. But looking at the data that we had, we recently started looking and evaluating at all of the features that we had launched. And by looking at the data, we're able to now prioritize and hone our focus so we can develop and put our time into what's really pushing the business forward. And so by focusing on the next step and using our data to optimize and hone our approach, this has helped us grow quite quickly recently. And we just launched one of our major new features, building upon our Coinbase exchange, which is where we're starting to focus a lot of our efforts inside. And that brings us to tip number 3, which is to embrace visualization. And I really like to start this with a quote from Drew Conway, who's one of my favorite data scientists. He has this great quote that human problems won't be solved by root mean square error. And as valuable as this is in statistics, this might be something we use heavily when we're in the depth of a problem. Some of the largest problems around us require more interaction with the people around us. And so one of the fun problems that we got to work on while I was at the agency was after we launched our Mars rover. This is a picture of the Mars rover Curiosity that we have on Mars now, bundled up with its sky crane, which descended it and dropped this on the surface of the red planet. But what actually happens behind this was, I think we had an estimate where some 11,000 people worked on this. And one of the main challenges of getting something like this to land safely on Mars is by harnessing the institutional knowledge that's really behind this. All of the people from the teams working on entry, descent, landing, to mechanical, electrical, structural, and hundreds of other disciplines inside. So while we were looking at some of the data that was available to us about the people that worked on this project, one of our execs came to us with a question. And they said, well, we know we've got all of this institutional knowledge captured up. What if we could see that brain evolve? What if we could see from the last Mars rover we landed to this Mars rover to the next Mars rover that we're planning to land in, I suppose, 5 years from now in 2020? How has our skill set evolved, and where do we need to focus our time to optimally curate those skills inside? And where this problem was started was just by simply looking at some of the data that we had inside. And by looking at something as complex as the collective institutional brain that we had inside, this was not a very effective way to look at how our skill sets were evolving inside the agency. And so by thinking about some of the visualization tools that were available to us, one of the tools that made a lot of sense for this was a flow diagram, or a Sankey diagram here, where we want to capture one state and look at where that state is evolving to, so maybe where we've hired more people or people have left to join some other discipline. And so we collected this, or we applied this to the data that we did have, and we made a Sankey diagram that visualized how our brain has evolved from year over year over year. And so this is looking at different skill sets across the lab that worked on the project in 2007 and how they split up to multiple disciplines around the lab in the following years. And so we called this our Career Paths project, which showed that flow throughout the organization. One of the second questions that came up after we were showing this to some other executives, it started to perk some ideas inside. And one of our other colleagues came up and said, well, that's really interesting. I hadn't thought about that when I looked at the spreadsheet. But now that I see that visualized, what if we could look at it the other way around? That's really what I want to see, is where did our people evolve from? And so we went back into our lab, we developed a little bit more, and we reversed the visualization so you can now pick a project today and see where you've drawn institutional experience from the other side of the lab. And we showed this off to some more executives inside, and this piqued some other ideas as well, where someone saw that and said, well, hey, that's really interesting, but now that I see that this is possible, what if we could look at how other types of people evolved in labs? What if we could look at leaders inside to see what the fingerprint of a leader looked like? And so after this, we went back into the lab, and we started building this out just a little bit more, where there's a video here we'll see if we can get to play. And so this became a fully interactive tool that was no longer constrained to just one way of looking at the picture, but by iterating with some of our leaders and going back and forth with ideas, we built a self-service tool for them to explore this data. And so one piece that I'll show off is my career path. And so by highlighting myself, we can see that in 2010, I was working on one project, but if we rewind a few years, I started on some small introductory projects at the lab. And by fast forwarding, I worked on a couple of different projects at the same time in the future. And this became a really relevant way for us to see how things are moving inside. So by providing a native way to visualize this and allowing our execs to look at this inside, this was one of the larger wins that we had. And this was something that I think was only possible because we were looking at new ways to visualize and make the data personal to our staff. With these visualizations, however, it's very important that we question what's inside of them. So whenever you see these, always question. It's very easy to be misleading with our data, and all of us as data scientists hold a tremendous amount of power. And we want to make sure we don't abuse that by sending the wrong message. Okay. Tip number 4 is then to analyze our data in real time and to start by designing our systems so that we can allow this real-time analysis to happen. One place where we saw this typically start was when we were looking at data in the lab. We would have an oscilloscope where we could look at a small snapshot of real-time data, typically a few seconds here, and then we would archive that data unidirectionally into a warehouse where maybe we would look at later if we had the time and resources. By applying some of the newer tools that we had, we built a real-time flow around this, whereby instead of sending this data off to a warehouse that we may or may not have been using, we built this fully interactive real-time flow on the web where you could look at and zoom into any portion of the Mars rover data from any time period that it had been on the surface. And by bringing this to the web, making it accessible to our engineers to in real time look at all of the data. This was very much possible with cloud computing behind it and some of the larger data systems that we had brought in. This helped dramatically increase the efficiency at which our team was able to analyze and thereby turn around new commands for our Mars rover. And again, when we showed off this visual to some people, some of the engineers on the project, they came back with another question. They said, well, this is really interesting, but what if we could add rapid context to that data? And some of the context that we focused on was when we see telemetry come back from the rover, we often want to see where the rover actually was or what the rocks looked like around it, which have a large impact on the actuators and the thermal environment for our rover. And so we liberated some of that data as well. We took all of the imagery that had come back, which was previously being stored on the equivalent of an FTP share. This was architected so that we could use cloud behind it, and we put a real-time search interface on top of it so we could quickly navigate all of the imagery that had ever been pulled home. And on top of this, we also built an API around it, which is really important when we put our data systems in, because the value that we get here is rarely in the first application. It's more often in secondary applications that we've enabled our engineers to use on top of this. And so what we did after that RESTful API was built was we were able to really quickly and easily tie this back into our telemetry search application so you could, in real time, not only look at your data, but also visualize that. And I'm going to crank because we're starting to run out of time. But for that real-time data that we're pulling in, there are ultimately a few things we want to do with that data, which is to know what's happening in our environment. We want to make a decision based upon that data, and we want to make that decision now. So of all the data producers that we have inside, we all have an extremely heterogeneous environment. I don't think anyone has one data producer. With all the data producers we have, there's some transformations we'll want to apply to that data. And ultimately, we're going to send it off to some analytics store. We might send it off to our production app or some other tools on top. And when we're connecting and providing, say, RESTful APIs in this actually doesn't scale very well. We get this exponential growth of interconnections inside. And so the way that we're designing everything inside Coinbase today is around a real-time streaming hub. We use Kinesis, but you can use Kafka or Storm or many other streaming tools. And by putting that inside, we get this really nice linearization effect, where instead of having that exponential growth of new connections, we can pull all of the data from all of our producers in real time and start to make intelligent actions on that. And tying this back to our first point, our infrastructure favors real-time data now, where we've classified the data that we send through this as appropriate for everyone in the company to see, so we make this extremely accessible inside. And one example that I would show is of all the data we pull in, we send this into an Elasticsearch Kibana stack on the other side, so everyone has a full-text search and a self-service query capability on top. We use this for some metrics as well. And this gives us a nice ability to also send these into other consumers like our chat room inside, which we make sure to link back to Elasticsearch as well. So we send a lot of links that send people back to the raw data source. And the last tip was to provide self-service, but I think we're out of time. So if you want to talk about self-service on data, I'm very happy to chat. We'll be around here for the rest of the day. So thanks everybody for having me, and I look forward to it.